when you think about the equation of a line, you probably think about the equation y equals mx plus b. B is the y-intercept, and that's a point, 0b. And then the slope m defines a direction. And that's what you really need to define a line. You need a point and then a direction from that point. You've probably heard the phrase that 2 points make a line. So if I look at 2 points, I can certainly draw a line through those 2 points. And then I can use those 2 points to find the slope using rise over run. And then, of course, once I have the slope and then one of those 2 points, I have the equation of a line. So we want to understand how this works in 3 dimensions. So the equation of a line through a point, that point is a vector r0, and in the direction of the vector v is going to be given by r0 plus t times v. That variable t is going to be called the parameter. Now, you may ask yourself, why is that the equation of a line? Well, r0 is going to be my point, and the vector v is going to define that direction. So let's see how that works. I'm going to start by drawing a vector r0. r0 is going to then point to the point r0. And then I want to add another direction vector. We'll call that vector v. So I want a line that starts at r0 and then points in the same direction as v. So let's look just at the vector r0 plus v. So what I'm going to do is add the 2 vectors together. That's going to give me, this point here is going to be r0 plus v. And if you look at the equation, that's the same thing as r of 1. So what I have with the orange vector is the start of a line. And then if I add any multiple of v to r0, what that's going to do is extend that vector infinitely in that direction. And if I add any negative multiple of v, then that's going to extend the line in the other direction. And so you can see if I have a point r0 and then I add to it any multiple of v, that's going to define a line. Now in 3 dimensions, we're going to use r0 a lot. And so that's always going to be some coordinate x0, y0, z0. And then we're going to think of our vector v as having 3 components. I'm going to call that v1, v2, and v3. And so using this equation, r of t equals r0 plus tv, we can actually define 3 equations. The first one is the x equation. X is going to be x0 plus tv1. There's a y equation, y equals y0 plus tv2. And then there's an equation, z equals z0 plus tv3. So we can write this as a vector equation for r of t, which of course is this line here. Or we can write it as 3 equations for the x, y, and z coordinates of that line. I want to show you what this looks like as a plot. So I'm going to plot this. And so what you have here is a similar plot to the one that I had drawn for you. And right now, the blue vector is like our R0, and it's pointing to that initial point. That point happens to be, in this case, 1, 1, negative 1. And then you can see the direction vector, that's the black vector, and then the red line going through that. And what's happening is that for every t value, we're updating that blue vector that's pointing towards a point on the line. So if I let t increase, then you can see that vector move through the line. So that's at t equals 2. Now I have essentially R0 plus 2v that vector is pointing at. And so you can see how for various t values, I get different points on the line. And I can go back the other way. For negative t values, I get different points on the line. So every t value is giving you an x, a y, and a z coordinate. And that's how we're defining the line. So this is a parametric equation for the line. We can ask some simple questions about finding the equation of a line. For example, find the parametric equation of the line that passes through the point 2, negative 1, 4, and is parallel to the vector 2i plus j minus 3k. So r of t, in this case, is going to be the point 2, negative 1, 4. And then we're going to add to that the vector v, which is 2, 1, negative 3, times t. At t equals 0, we get the point 2, negative 1, 4. And then for every other value of t, we get a different coordinate that's on that line. Now, I said before that 2 points make a line, so I should be able to take these 2 points P, which is negative 1, 2, and 3, and then the point Q, 2, negative 3, and 1, and I should be able to find a line that goes through those 2 points. So first, I just want a vector V that starts at P and point towards Q. So I need my vector B to be the point, or the vector PQ. So I need to take the point Q and then subtract the point P. So 2 minus a negative 1 in this case gives me 3. Negative 3 minus 2 gives me negative 5. And then 1 minus 3 gives me negative 2. So the vector 3, negative 5, negative 2 starts at P and then points towards Q. Now that I have the vector V, I can just write R of t, and that's going to be equal to the first point, P, negative 1, 2, 3, plus t times my vector. My vector in this case is 3, negative 5, negative 2. You can do a quick reality check. If you let t be 0, then you get the point P. And if you let t be 1, then you should be able to verify for yourself that you get the point Q. So R of 0 in this case is going to be P. And then R of 1, you can verify for yourself, is actually going to be Q. So sometimes it's nice to think of my equation of a line, if I've got 2 points, as being R of t equals the point P plus the vector PQ times t. Now, sometimes you'll see in the book, they like to write this as 1 minus t times the point P, negative 1, 2, and 3, and then plus t times the point Q, which is 2, negative 3, and 1. And you can use vector addition to verify that this different way of writing the equation of the line will match my original equation of r of t. So if you multiply out the 1 minus t and then multiply through the t times the 2, negative 1, or negative 3, 1, then you should be able to add everything up here and get the equation that you had here. So that's another way to express the equation of a line. Sometimes the book likes to write it as 1 minus t times p plus t times q. And that will actually give you the same equation. Now, we're going to say that two lines are parallel if they have the same slope. But instead of slope, we're going to say that the direction vectors for those lines are multiples of each other. So if the direction vectors are multiples of each other, then those vectors are parallel, and then therefore the two lines are parallel. Now in 2 dimensions, you either had lines that were parallel or you had lines that intersected. But in 3 dimensions, we can have lines that are parallel, you can have lines that are intersect, and you can also have 2 lines that do not intersect and are not parallel, and we call that skew. So to convince yourself of this, just take 2 pencils and put them in your hands, and then create 2 parallel lines with those pencils. And then you can create 2 intersecting lines with those pencils, and then see if you can figure out a way to orient those pencils so that the 2 lines are not parallel, but they're also not intersecting. I'll show you a picture of that in a moment. But first, I want to look at these 2 lines, L1 and L2, and I want to show that they are skew lines. Okay, so L1 is going to be x equals 1 minus t, y equals 2 minus 2t, and z equals 3 plus t. And then L2, I'm going to use the variable s instead of t to distinguish the two. So that's going to be x equals 2 plus s, y equals 1 minus s, and z equals negative 1 plus 2s. Okay, so now first I can just look at the direction vectors. So the direction vector for L1 is the coefficients of t, which are negative 1, negative 2, and 1. And the direction vector for the second line are the coefficients of s, and those are 1, negative 1, and 2. And it should be pretty clear that v1 and v2 in this case are not multiples of each other, and so these lines are not parallel. Now the question is, do these lines intersect? Well, if these lines intersected, then I should be able to set the 2 x equations equal to each other, the 2 y equations equal to each other, and the 2 z equations equal to each other, and then they should intersect at a specific t and s value. So what I'm going to do is I'm going to look at the x equation, which is that 1 minus t would have to equal 2 plus s to have the 2 lines intersect. And then I would have to have that 2 minus 2t would have to equal 1 minus s. So these are the x equations and the y equations. So I would have to have at least those 2 equal, and then I would also have to have the z equations equal to each other, which I'll look at in a moment. But just looking at the x and y equations, you can see that I can add the 2 equations together, and then I get 3 minus 3t is equal to 3. that tells me that negative 3t is equal to 0. And then t must equal 0 for these two lines to intersect. Now, knowing that, I can look at the x equation with t equals 0. Looking at that x equation, I have that 1 minus 0 is equal to 2 plus s. And so that tells me that s has got to equal negative 1. So in order for these two lines to intersect, they have to intersect when t is 0 and s is negative 1. So what happens if we stick that into the z equation? So the z equation says that 3 plus t has to equal negative 1 plus 2s. But if I specifically stick in that t is 0, I'm just going to stick it in, and that s is negative 1, then I'm going to get 3 plus 0 is equal to negative 1 minus or plus 2 times negative 1, and then 3 would have to equal negative 3. And therefore, the two lines must be skew because there's no t and s value for which the x equations, y equations, and z equations are all equal at the same time. So this cannot be true, and so we can say that the lines are skew. Now I want to show you what that would look like in 3 dimensions. So what I'm going to do is I'm going to plot these lines for us. So I'm going to plot the two lines. So this was the first line, L1, and this is the second one, L2. And I want you to notice as I rotate them around that it's obvious that the two lines are not parallel and that they don't intersect. It appears that they intersect, say, there, but they don't. If you look at the perspective on it, you can see that one line is kind of going underneath the other line, and then they never quite intersect. So these two lines are skew. So they're not parallel and they don't intersect. Now, if I was to change the green line, so if I was to change this, instead of negative 1, making it 5, then the two lines would intersect, and they would intersect at the point 1, 2, 3 that I've kind of highlighted there. Now you can see that they intersect. So if the intercept had been 5, or sorry, if the point had been 2, 1, 5 instead of 2, 1, negative 1, then I would get that the two intersect.